guys, in this video I am going to be covering 6.3 day 2, and so we've just worked on polynomial long division, and I'm going to show you another method for dividing. This method is called synthetic division. It's definitely quicker than long division, but it does have some restrictions. So long division always works. Synthetic is more efficient, but we can only use it in certain instances. So here is when we can use it, when we are dividing by something in this form. So the big thing is that the coefficient on x must be 1 in order to use this. It's good to know that it's going to reduce our polynomials by 1 degree, and this method actually doesn't use variables. So here's how it works. We are going to identify what x equals if x minus a is a factor. So if I'm dividing by x plus 1, I want to know what a is. So the short way to do it, or I should say the long way to do it, is set x plus 1 equal to 0. So then x equals -1, right? Subtract 1. The quick way is just, it's the opposite of whatever we're going to see here for the number. So what is going to happen is that is a 0, okay? We are going to put, sorry, I shouldn't say that yet. We actually don't know that yet. So whatever x equals here, when I set that equal to 0, I'm going to put in this little box here, okay? Then the dividend, the thing that's being divided, we are going to list all the coefficients. The big thing is I want this to be in standard form, which it is. And the coefficient on x squared is 1. Then the coefficient on x is 3. And then the constant is 5. I'm going to put a line underneath. And the very first thing I'm going to do is I'm going to bring down the 1. Okay? Then the process of synthetic division is I'm going to multiply -1 times 1 and put the product here. And then I'm going to add. So 3 plus -1 is 2. And then I just repeat. So -1 times 2 is -2. 5 plus -2 is 3. The last number I also kind of like to put in a box. This is the remainder. This is the quotient, the answer, but it's not in its exact form that I need. I need to put the variables and the exponents back in there. So I started with a second degree. When I use synthetic division, the degree is going to go down by 1. So this means this is going to be x to the first, and this will be x to the 0 or a constant. So I have 1x plus 2. And then plus the remainder, 3, and then remember the remainder always goes over whatever we were dividing by, x plus 1. So that is our answer to that division problem. Okay, let's try another one. All right, here I'm dividing by x minus 3. That's the right form for synthetic. So the number that's going to go in the box is going to be 3. Okay, so now here my highest exponent is 4. So I want to start with listing on the coefficients, but notice it skips from 4 to 2. I need to put a 0 in place of the x cubed. So I have 1x to the 4th, 0x cubed, -10x squared, 2x, and 3. Draw my line. Okay, bring down the first one. 3 times 1 is 3, and then add. 0 plus 3 is 3. Repeat. 3 times 3 is 9. Add, get -1. 3 times -1, -3. Add, 3 times -1 is -3. Add, and we get 0. So in this case, my remainder is 0. Okay, so how I write my answer, I need to put the variables and exponents back in there. So it started with a 4th degree. So that means the highest exponent I'm going to have is a 3rd degree. So I have 1x to the 3rd, 3x squared, -1x, and then -1. Okay. Okay, this one here, I'm dividing by x plus 2, so it's in the nice form for synthetic division. -2 is what's going to go in our box. Okay. Highest exponent is 3, and it goes down by 1 each time, so we just need to list the coefficients. 3, 8, 5, and then -7. All right. Bring down our 3. -2 times 3 is -6. Add. -2 times 2 is 4. Add. -2 times 9, -18. And add. So this one I have a remainder of -25. I started with a third degree, so after dividing, what's left is going to be a second degree. So I have 3x squared plus 2x plus 9, and then minus 25 over x plus 2. All right, okay, let's try another one here. Okay, I'm dividing by x minus 4, so 4 goes in the box. Coefficients, I have 1x to the fourth, negative 2x to the third, 0x squared, negative 31x, and negative 4. Bring down the 1. 4 times 1 is 4. Add. 4 times 2 is 8. Add. 4 times 23 is what? 92, I think? Oh, sorry, I missed one. I missed my 0. All right, let's try that again. So 4 times 2 is 8. Add. 4 times 8 is 32. Add. 4 times 1 is 4. So 0 is our remainder. So my solution, I start with a fourth degree, so this is a third degree. So 1x to the third, 2x squared, 8x plus 1, and no remainder. All right, so something good to know is that if we see x minus 4 in parentheses, so includes the variable, that is what we call a factor of p of x, and that's if it divides evenly. So it divides evenly if there's no remainder. So if there's no remainder, x minus 4 is a factor of p of x. And just the solution, right, what goes in the box is what we call a 0 of the function. All right, so this one says factor given that negative 3 is a 0. So if negative 3 is a 0, that's what goes in the box. Okay, we're going to divide using synthetic division. So here I have a third degree, nothing to the second power, negative 13, and then negative 12. Bring down our 1. Negative 3 times 1 is negative 3. Add. Negative 3 times negative 3 is 9. Add. Negative 3 times 4 is positive 12. Add. So this went in evenly. Okay, so that means for sure x minus negative 3 or x plus 3 is a factor. So if negative 3 is the 0, x plus 3 is the factor. So here I have x plus 3 so far. Here's my leftover polynomial. So I started with a third degree. So what would be left is a second degree. So it's 1x squared minus 3x minus 4. And now this is a trinomial that I can factor further, right? Numbers that multiply to be negative 4 that add up to be negative 3 are going to be negative 4 and positive 1. So this would be completely factored. All right. If 2 is a 0, use synthetic division to factor. So this is exactly the same thing. So if 2 is a 0, 2 goes in the box, and x minus 2 is the factor. So I know I have x minus 2 times something, okay? So I have 1x cubed, 0x squared, 1x, and negative 10. Bring down the 1, multiply, add, multiply, add, multiply. Okay, so what's left is 1x squared plus 2x plus 5. All right, so now numbers that multiply to be 5 that add up to be 2. I can't factor further than this, so this would be completely factored as it is. All right, so synthetic substitution I can use to evaluate a polynomial for a specific value. It's the same exact process as synthetic division, but we're going to interpret our final answer a little bit differently. So if the polynomial function p of x is divided by x minus a, the remainder r is the same as p of a. All right, so let's see what we got here. Okay, so here's kind of what this is talking about. We can use synthetic division to evaluate a polynomial. So I am going to use negative 2 as my 0 in the box, and I'm going to list out my coefficients just like before. Okay, perform synthetic division. All right, so here, -6 is my remainder. So if it's not a 0, it doesn't go in evenly. This remainder is actually what p of -2 equals. So in other words, if I had plugged -2 in to this polynomial, it equals -6. This is just another way to do that using synthetic division. So p of -2 is -6. Okay, we're going to try this with this next one as well. So I'm going to put 5 coefficients 2, 7, 2, 1. Perform synthetic division. Let's see, 5 times 17, 20, 100 minus 5, 95, I believe. That's not right. Let's see, that's 85. There we go. Okay, and then add. Oh boy, I'm getting big here. All right, so 5 times 87 is 435. So 444 is my remainder. Oh, 34, excuse me. Wow, I'm all over the place. 436, adding 1. Okay, so P of 5 is 436. Okay, so kind of some different things between polynomial division, or excuse me, long division with polynomials or synthetic. Remember, in synthetic, terms are added. Okay, in synthetic division and in substitution, terms are subtracted in long division. That was the piece where we said draw the line, change the sign. Subtraction, that sign is distributed through changing all the signs. All right, guys, that is it for synthetic division. Thanks for watching.